Hey everyone, so I'm going to do a video on simplifying radicals. So I'm looking at my first expression here. I have the square root of 4. In order to simplify the square root of 4, I'm going to have to think of what factors are inside of 24 where one of them will be perfect. And the one that I can think of is 4 and the square root of 6. So I have the square root of 4 and the square root of 6. So what I can do now is I can reduce 4 into the square root of 4 becomes 2, and I'm left with 2 square root of 6, and this is my final answer. Now my next expression, I'm going to also break up 45, just like I broke up the 24. So I have 45. 45 breaks up into the square root of 9 and the square root of 5. Okay. 9 being the perfect square. I'm also going to write the square root of p squared in its own radical. The square root of 9 is just 3, and the square root of 5 stays the same because it's not perfect. And then p squared becomes p. The reason why p squared becomes p is because it's p times p, which becomes p squared. Because that's the case, when you take a square root, you undo something times itself, so it just becomes p. I'm going to bring everything that's outside of a radical to the front, so I get 3p, the square root of 5. So with the next example, I'm going to analyze how to deal with powers and letters. So the one thing that I want to keep in mind for you guys is that the index here, the index is the thing that is between the radical symbol and this little like swoosh here. In this case, you don't see an index. Sometimes you see a 3, which means a cube root. Sometimes you see a 4, which means a fourth root. But in this case, you don't see anything, and it's understood to be 2 when you don't see something. Okay, so because of that, we're going to institute this rule that I taught you, power over root, or power over index. So I'm going to have w 12 over 2, and that becomes w to the 6th. That's your final answer here. You could also just take the square root of 12 and you end up getting w to the 6th. But the reason why it happens is because it is 12 over 2. Okay, now if you look at the next one, m to the 11th, that has a power of 11. That does not divide evenly by 2. So what we're going to do is we're going to split this up into the next even power. The next even power from 11 will be 10 and 1. The reason why I need another m to the first is because I can't really get rid of 11 m's. I need to just break them up. So I first have my m to the 10th, and then that m to the first makes me still m to the 11th. So I'm going to simplify m to the 10th to m to the 5th, and then the square root of m to the first will stay. The next question, I'm going to break this down even further. I'm going to break it up into 3 radicals so you guys can see how to break down each piece. Okay, the square root of 16 is 4, and the square root of u to the 4th is u squared. Now, if you notice, v cubed is an odd power, so I'm going to have to split v cubed up to the square root of v squared, again going down to the next even power, and the square root of v. This allows me to further reduce and make v squared, the square root of v squared, just v, and then the square root of v stays inside the house because it's not perfect. My next problem is a little bit different because the index is 3, meaning that I have to find a perfect cube instead of 24. The perfect cube that is inside of 24 is 8, so I'm going to rewrite this as the cube root of 8 and the cube root of 3, because 3 times 8 is 24. So then I'm going to have the cube root of m cubed separate. Okay, so the cube root of 8 is just 2, because 2 times 2 times 2 is 8. The cube root of 3 will have to stay because you can no longer simplify it. And remember the power over index thing. If I divide 3 by 3, I end up getting m to the first. So my final answer is 2m cube root of 3. Okay, I hope this video helped you guys. I'll see you soon.